Hello, and welcome to Golden Droplets, a webinar intended to close the gap between the industry and the academy. In today's episode number 43, we are going to be talking about a very interesting problem, which happens when you are forced to work with data from two different labs with different below detection limits and other characteristics. So, once again, Golden Droplets, episode number 43. Enjoy. Many times we are confronted with the situation that we get data from two different labs or even a same lab, but that has used a more advanced method, and the below detection limits for the two data sets are different. For example, in one case is 0.1 and in another case is 0.05. What to do? Well, the most simple solution is to work with each data set separately, which means you're going to be doing double the work. And of course, there will always be a problem when you're trying to put together the result of those two processes. If you have access to the pulps, that is the best situation, you just do a reanalysis of the below detection values for the lab or the technique that has the higher below detection value, and that's it. You're done. You can work. For example, let's say these are two groups of data, goal 1 and goal 2, and the below detection limit for goal 2 is 0.5, while the detection limit for the goal 1 is 0.05. This is the more modern thing. So, as I said, if you can do the reanalysis for those missing values of 0.5, and then you just do a regression analysis, and that way you can convert the old values of goal 2 into the new values of goal 1 using this regression equation. And usually has a very good fit because you are actually reanalyzing the same sample. But what can we do if we don't have access to those pulp or those samples? Well, the best solution will be as follows. You can organize all your data from the maximum values to the minimum values, like here. And then you determine the first quartile for each group. Quartile, the formula is quartile of the whole data, comma 1, that will make the first quartile. And in this case, the first quartile for the group 1 is 5.86, which are highlighted here in yellow. And for the group 2 is 7.07, which are highlighted here also in yellow. Next, we need to find a regression between these two groups. And because regression only works with pairs, I can only select the first 5 pairs of this group in order to do my regression analysis. And then I just do the study, and I got and obtained this equation, which means that in order to convert the value of the goal 2 of the oldest data, I need to use this formula, like minus 5.54 plus 2.07 by the value of the goal from the new method of goal 1. And then once you have converted all your below detection values to the new value based on the goal values of the group 1, then you can unify all your values into one column, and now you can do your work for this group of data. Of course, summarizing, the best thing is to have the possibility of doing a reassaying of the below detection limit for the oldest method, but if not, this method will help you solve this situation, which regrettably is very common in the practice of geochemistry. So I hope this will be helpful. And as always, I welcome your comments and questions. You can write me to my email at valls@gmail.com or leave a comment down here at the site that you're using to see this video. Until next time, have a great day.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.